equilibrium of forces, when the forces are not just pointing up, down, left, right. But these kind of questions are very simple, guys. We just make them point up, down, left, right. So we can see we have three coplanar forces, meaning they're on an xy axis shown below, and they're all in equilibrium. Find the value of x and theta in order to ensure that this system is in equilibrium. Equilibrium meaning all the forces are balanced. Now obviously we have this is our x-axis and this is our y-axis. So all the forces need to be pointing in the direction of the axes it's sitting on. So because we have an x and y axis, everything needs to be horizontal, everything needs to be vertical. However, in the future, we're going to look at inclined planes. Now, inclined planes are slightly different when an object is sitting on an inclined plane. Your x-axis is actually this, and your y-axis is obviously perpendicular to that. So if we have forces pointing, you know, all of this kind of stuff, we need to make sure they're pointing up and down the hill and out and into the ground. But we're not dealing with that just yet. So, very soon though. We need to make sure all the forces, horizontal and vertical, and that's very simple. Like I said in a previous video, guys, to be good at mechanics means to be good at just doing SOHCAHTOA. So as long as you can do SOHCAHTOA, you're chilling. So we have this particle here, x is pulling it this way. Now that's pulling to the right and is pulling up. Yeah, triangle of forces. Now x is in the hypotenuse, just like we did with moments. It's the hypotenuse sine or cos of the angle. Now because this is opposite, it's the hypotenuse sine of the angle. Then this is going to be the hypotenuse cos of the angle. So that's done. I want to cross it out, but it's already across. Okay, doing the same thing here. What is that 50 newtons doing? It's taking this particle and pulling it down, and it's pulling right. 50 is the hypotenuse. This is the adjacent, because here's our right angle. So the adjacent is between the right angle and the angle in question. So it's going to be 50 cos 20, and this is going to be 50 sine 20. Get rid of that. And here's my 40 newtons. That's obviously pulling the particle to the left, if I know my lefts and rights. So that's 40 cos 10, because there's my triangle. So it's pulling to the left and up. So 40 cos 10, the adjacent side. And then we've got 40 sine 10. Okay, all these forces have been resolved. I've ticked them off. Now, it's just a simple case of balancing everything. So now we're going to resolve up and down. And we're going to say, okay, whatever's pointing up must equal what's pointing down, because the particle's not moving, right? So up is x sine theta. And 40 sine 10. That has to be equal. Let's cross these off. That has to be equal as pointing down, 50 cos 20. Now guys, don't type anything in the calculator. Just rearrange for x sine theta, and then I'm going to show you guys how we can solve this stuff. Super easy. You don't need to think of this in terms of simultaneous equations. So we have minus 40 sine 10. Okay, now let's look at the left and the right. So looking at my left and right. X cos theta. Anything else? Yep, 50 sine 20. Must be equal to 40 cos 10. Has everything been ticked off? Yeah, it's looking good, mate. So we rearrange x cos theta is 40 cos 10 minus 50 sine 20. All right. Now, what students do here is they divide, they do inverse tan, they take that, they substitute it, divide again, and it's just a mess. Okay? So I'm going to show you guys what I would do without actually doing this step, but just showing you what's going on in my mind. Okay? Now remember, this is a triangle. Yeah, what we worked out is that this side here, which was x sine theta, is 50 cos 20 minus 40 sine 10. And this here, which was x cos theta, is 40 cos 10 minus 50 sine 20. So if you just remember that these are just the sides of the triangle, we can easily work out theta by doing inverse tan of this over this. And to work out x, which is in the hypotenuse, we just do Pythagoras to these values. So all I would do is now I'll type these in and store them as a and b. Then to work out theta, we're going to do inverse tan of the opposite a divided by the adjacent b, then we'll round it. Then x is going to be Pythagoras to our coefficients. We'll do everything to the nearest whole number. So typing this in, I have 50 cos 20 minus 40 sine 10. So that's about 40, so I'm going to store that as a, like I've said. And then I have 40 cos 10 minus 50 sine 20. About 22, so I'm going to store that as b. So now doing inverse tan of a over b, I get about 60.89. So let's say 60.9 degrees to 3SF. And then we'll do root a squared plus b squared. Oh, whoa, that gives me a really nice number, 10 root 21. Dude, I was not expecting that. Dude, I literally just made this question up like 2 minutes ago. Or however long this video was, has been going on for. Dude, sick. That's your answer. Alright guys, I'd appreciate if you hit the like button, especially since I just made this question up. It worked out beautifully. So like the video if you learned something, subscribe for more maths content. If you're interested in my A-level maths courses, more details in the description. And feel free to join the Learn Gang Reddit page if you want to submit your own questions and get feedback from the community. I'll see you in the next video. Nice.